Alright, so today we're going to focus on factoring trinomials with the area model. And we've been using the area model for a while now, but in the past we've had all 4 boxes already filled in for us, or enough information to fill them in. Now we're going to be focusing on things that only have 3 terms, so part of the challenge is to figure out how to break up this middle term into 2 terms that I can put in these 2 empty boxes. Alright, so it says, so far we've been factoring quadratic polynomials with 4 terms. What if we don't have the 4 terms? What do we do with that 5x? The first and last term you can always fill in immediately, and anytime you're working on these, that's the first thing I'm going to ask you to do before you can ask for help, because this is the same each time. Whatever that first term is, and whatever that last term is, you automatically fill in the box, no matter what. It's that middle term that we're trying to kind of break apart. But we have to do it in a very specific way. So one of the things we've talked about is that the diagonals have to multiply to the same thing. So x squared times 6, that's just 6x squared. So I know that whatever this times this is, it also has to equal 6x squared. Not only that, but it has to add up, when I add them, to 5x. So basically we're asking the question, what 2 numbers add to 5 and multiply to 6? And a lot of times we kind of start with the second part because that's how we get our possible numbers. So things that multiply to 6, we have 1 and 6, and we have 2 and 3. And there's only one pair that multiply to 6 and also add to 5, and that's going to be a 2 and a 3. Okay, so that's the number part. Okay, so 2 and 3 add to 5 and multiply to 6. So I know that there's a 2 and a 3. But not only do they have the numbers, they also need to have an x with them because they represent that 5x term that we broke into 2 things. So one way we can write 5x is to break it into 3x plus 2x. Okay, let's see, so we're going to do 2x and 3x. Now, could I switch the order of the 3 and the 2? Absolutely. I could have put my 3x here and my 2x there. It doesn't make a difference. But it does have to meet this criteria of adding to 5 and multiplying to 6, because now we have 2 diagonals that multiply to the same thing. All right, and so from there we can actually factor. So we know the only way to get x squared is to do x times x. And we always start with this first box every time. And once we have that, it's kind of easy to go from there. So x times what is 2x? That has to be a positive 2. X times what is 3x? That has to be a positive 3. So we get x squared plus 5x plus 6 to factor into x plus 3 times x plus 2. And again, we could write that in either order. You can put the plus 2 and then the plus 3. It doesn't matter. All right, so on the next page, there's some quick review with signs because this is very important. This can be a lot harder if we're not good at remembering our positive and negative rules. So whenever we're multiplying things with the same sign, we get a positive answer. And when we multiply things that have different signs, we get a negative answer. Okay, so that's something to remember. It's different rules than when you're adding positives and negatives. All right, so whenever we do these problems moving forward, we're going to use this thing called the X factor. And it's just a way to organize what we're thinking about when we're trying to fill in these missing spaces. So we're looking at this same example we just did. In order to find the 2 missing terms, we will use the X factor. We will not include the variables of our X or x squared when filling it out, but just focus on the numbers. But you have to remember if it's coming from the X factor, it's going back in here with x's as well. Okay, so again, we found that the 2 numbers were 2 numbers that multiplied to whatever this multiplies to. And remember, if you have an x squared with nothing in front of it, that's like a 1 times 6. So that number goes up here. That's what they have to multiply to. And then the number that we're breaking apart, the 5x, the 5 is what they have to add to. And so the 2 numbers we found that do that were 2 and 3. And again, when we bring them from the x factor, we put them back in the boxes with an x as well. So that's not just 2 and 3, it's 2x and 3x. And this is here for a reason. It does not matter which one you put here versus here. It'll give you the same answer. So the area of the rectangle as a sum is when we add up the inside, and that's actually what we started with. So it should give us back what we started with, which is x squared, and then the 2 and the 3 added to 5x. That's one of the things they had to do. And then the plus 6. And then the side lengths, again, we already factored this, so I'm just going to go through it quickly. We got an x with a 2 and an x with a 3, and that multiplies to 6 like we like. So the factors, or the length and width of the rectangle, are x plus 2 and x plus 3. Okay, and that's the area as a product. All right, so let's try some from beginning to end here. All right, first thing we do no matter what is put the first term and the last term in the first box and the last box. So I'm going to put an x squared here, and I'm going to put a plus 35 here. Everyone can do this step, and I will expect you to do this step. Okay, now we're looking at what it has to multiply to. The two numbers have to multiply to 1 times 35, which is 35. And then they have to add to 12x. So we're thinking of two numbers that multiply to 35 and add to 12. And sometimes you might have to make lists, like 1 and 35 multiply to 5. 2 doesn't work because it's not even. 3, no. 4, no. But 5 and 7 work. And those are the only factors that work for 35, so two of these have to give us 12. And if we look closely enough, you can see that 5 and 7 will actually add to 12, which is what we want. Okay, so that means in this box I'm going to put a 5x, and in this one I'm going to put a 7x. Okay, and then we factor from there. So we're going to put, let's see here, we're going to get an x times x for x squared. We always start with the first box. X times what is 5x? That's going to give me a 5. And then x times what is 7x? That's going to give me a 7. And then this last box is kind of like a check. Like if this works, you should be okay. If it doesn't, go back and look at what you did. And luckily 7 times 5 is 35, which is what we wanted. So our two factors are x plus 5 and x plus 7. Doesn't matter which one you write first or second. Let's try another one. So again, my first step is to fill in the first box and the last box. Always start with that. What do these two things multiply to? Well, 1 times negative 2 is negative 2. And then it needs to add to whatever this middle term is. And we don't ever put x in here, like we don't put variables in there. We only put numbers. So you're thinking, what's the coefficient? And if it doesn't have a number that you see, that means the coefficient is 1. All right, so let's think about this. It has to multiply to negative 2. Well, the only things that multiply to 2 are 1 and 2. And if it's negative, either the 1 is negative or the 2 is negative. So those are my options. And I know when I add the two numbers, it has to give me 1. So negative 1 plus 2 does give me positive 1, which is what I would like. 1 plus negative 2 would give me a negative 1 here, and this was not negative, so I'm not picking that one. So I'm going to put a negative 1 and a positive 2. Do a quick check. This times this is this, and this plus this is that one. All right. So I'm going to come down here. I'm going to put negative 1x and 2x. All right. So what multiplies to 1x squared? That's just x times x. All right, x times what is negative 1x? And it's going to be a negative 1. X times what is 2x? That's going to be a 2x. And then do our little mental check here. Oh, no, it's not. Ooh, that would be a 2x squared. We don't need that x. See, and I could tell that was going to be wrong. Like if I had left that and I did a little check here, that's not a negative 2x, so something's wrong with what I put. Okay. So yes, we're going to have 2 times negative 1, which is negative 2. So one factor is going to be x plus 2, and one factor will be x minus 1. Alright, so I'm just going to go through a bunch of examples here. You might be able to do some of these without waiting to see what I get, but I'm going to work through this page anyways, and then the next page you'll be able to tackle on your own. Alright, so here I'm going to fill in x squared and a plus 10. So that means that it needs to multiply to 1 times 10, which is 10, and it needs to add to 7. Okay, so two things that multiply to 10 could be 1 and 10 or 2 and 5. That's it. Those are only options. And the only one that actually adds to 7 is the 2 and the 5. Alright, so I'm going to put 2x in one of the boxes, 5x in another. Start with this first box, and as you'll see for most of these today, it's pretty straightforward, and it's just x times x gives me x squared. X times what is 2x? That's just a 2. And x times what is 5x? That's just a 5. And hopefully this last box checks out, and 5 times 2 is 10. So we're good to go. So this becomes x plus 5 times x plus 2. Alright, number 2, we're going to fill in x squared, we're going to fill in 8. So it has to multiply to, again, always implied to be a 1 if you don't see a number. So 1 times 8 is 8, and it has to add to 6. Okay, so let's think about this real quick. Alright, so 8 we can get with 1 times 8 or 2 times 4. That's about it. So the 2 that also add to 6, that looks like it should be 2 times 4. Okay, so 2 and 4 multiply to 8, add to 6. So we're going to get a 2x in one box and a 4x in another. So x times x is x squared. X times 2 is 2x. X times, oops, nope, not that one. X times what is 4x? That's going to be a 4. So I get an x plus 4 and an x plus 2. Alright, so the first two aren't so bad because everything's positive. These get a little bit more complicated when we get subtraction or negative signs involved because you really have to be careful with your addition and multiplication rules with negatives. So let's try this one here. I have x squared and 15. So this means that it's going to have to multiply to 1 times 15, which is 15. It's going to have to add to negative 8, which means we're going to have some signs that are the same because it multiplies to a positive number, but it adds to a negative. So what let's see what that looks like. So 15 I can get from 1 times 15 or 3 times 5. Now they have to have the same sign again because the 15 is positive. But because it adds to a negative 8, that means the same sign they have to have is a negative. So when we take a look at that, the two that add to negative 8 are the negative 3 and the negative 5. So always check. This is the hard part, guys. Like if you can get this part down, this part is not hard. But this is where a lot of you are going to struggle because we don't know our factors and we forget our negative rules. Okay, so a negative times negative is positive 15, and a negative plus another negative gets more negative to negative 8. So that is what we're looking for. So negative 3x and negative 5x. And now we get to factor. So x times x is x squared, and then x times what is negative 3x? That's simply negative 3. X times what is negative 5x? That has to be negative 5. Now here's where we check. Is a negative 5 times a negative 3 positive 15? Because they have the same signs, it does end up giving us a positive. So our answers will be x minus 5 times x minus 3. Alright, so ones like number 4 often stump my students because there's clearly something missing. Okay? So when we fill in our boxes, we always do the first one and the last one. And what you notice about those terms is it's the squared term and the constant term. It's the middle guy with just the x that we're breaking apart. Well, here, the part that's missing is that middle term with the x. So a lot of times I'll ask students to rewrite this as x squared plus 0x minus 9, because that's what's really happening here, and they're just not writing it, because we don't write things that are just plus 0. But in this case, it kind of helps to see that middle term. So the first term is here, and it's x squared, and the last term is here, and it's a minus 9. Okay, so it has to multiply to 1 times minus 9, which is a minus 9, or negative 9, I should say. What it adds to is what we can't see in the original problem, which is 0. So I need something that multiplies to negative 9 and adds to 0. I don't know what that could be. So I'm just going to start listing the factors of 9 first. So I have 1 times 9 is 9, and 3 times 3. Now, when we multiply these numbers, we're getting a negative, which means they have to have different signs. So one of them has to be positive, and one has to be negative. So we really could have that, or we could have that. And then 3, 3, they're the same. So if I make one negative. Now, the only way something can add to 0 is if you add a number plus its opposite, right? So in this case, this is what we're looking for. We're looking for that same factor twice, one positive, one negative, because that's the only way something can add to 0, is a number plus the negative of that number. So we're looking for negative 3 times positive 3, which gives us negative 9 when we multiply and 0 when we add. So we're going to put 1 here and 1 here. Now comes the fun part. Most of you will find this part pretty easy. So x times x is x squared. X times what is negative 3x. That's simply negative 3. X times what is positive 3x. That would be positive 3. And here comes the check. 3 times negative 3 is negative 9. So the two factors here are x plus 3 times x minus 3. In this particular type of problem that has the middle term not show up is called the difference of squares, and you'll see these occasionally. And you'll notice a pattern with the answer where it's always that same number twice, but one is positive and one is negative. So it's a pattern. If you like patterns, something to look for. Otherwise, you can just do this whole process every time, and there's nothing wrong with that. All right, last two. We have an x squared plus 1. So that means it has to multiply to 1 times 1, which of course is 1, and it has to add to a negative 2. Well, 1s are easy because guess what? The only way we get a 1 is to multiply 1 times 1. And we know it has to be the same sign because this is positive, but it must be the same negative sign each time since that is negative 2. So it should be a negative 1 and a negative 1. So that does what we want. We get a negative 1 times negative 1 to give us a positive 1. And when we add a negative and a negative, it gets more negative. Fun, fun, fun. So negative 1x here, negative 1x here. What's going on here? So we get x times x. X times what is negative 1x? Guess what? It's negative 1. And then we have the exact same thing right here. So this is a special example as well because we get the same factor twice. So you can leave it written that way, but when we multiply something times itself 2 times, another way you're going to see this written, like on a multiple choice answer, is that factor squared, because that means it was multiplied by itself 2 times. So that's the way we're going to want you to write it moving forward. Just a heads up. All right, last but not least, x squared minus 20. Okay, has to multiply to 1 times negative 20, and it has to add to, again, you can't put negative x here. Don't do that, okay? What we're really going to put is negative 1, because that's the coefficient. This one's going to be a little bit harder, because 20, let's see, we could have a 1 times 20, a 2 times 10, 4 times 5, and then you'll see, like, once you get here, you're just going to start cycling back up. Okay, so they multiply to a negative, which means that one of them's positive and one of them's negative. And when we add them, we still have a negative sign left. So that means that the bigger number in each pair has to be the negative one. So it has to be negative 20, negative 10, or negative 15. Let me rewrite that real quick. There, now you can see it a little better. We know the bigger one has to be negative when we add it and have negative left. So how do I get a negative 1? 1 minus 20, isn't it? 2 minus 10 is negative 8. 4 minus 5 leaves me with negative 1, and it multiplies to negative 20. That's the process that's going to take some practice for most of you. Okay? So be patient with yourself. You'll get the hang of it. All right, so we've got an x times x. X times 4 gives me 4x. And then x times negative 5 gives me negative 5x. And then negative 5 times 4 is negative 20, so we're good to go. We simply get x minus 5 times x plus 4. Awesome. So what you're going to do now is you're going to turn the page, and you're going to do these problems here. Now, what you'll notice is I didn't draw the stuff for you, right? So you're going to have to draw your own box and your own little X factor, because on a test, this is all you're going to be given. They're not going to draw that stuff for you, so you do need to get used to drawing it in yourself. So on each problem, you need to take a second and draw your little window box and probably draw a little X factor in. And then you can go ahead and give it a shot.